Welcome all. This is a small problem here. These three measures are very, very important. The first one here is tau, discounted mean term. I explained already. And the second one is volatility VI, and the third one is convexity. These are the three measures. Okay. So for this simple problem, we'll try to find tau, VI, and CI. There is a link between tau and VI. We'll try to establish through this problem. If you remember, we already solved one problem last time. So today I'm doing the second one. Okay. So if you go by the formula for DMT, it will be 5 discounted value. You write the present value here. Discounted value of 5, that is 5V plus discounted value of the second 5V square. Instead, we can write an annuity here. This will be 5A4 plus 100 V4. However, here you can't write in the annuity form. We'll transform finally. That's a different thing. We have to write the time here. Okay. Even if you want to see, let me write everything here. I don't know whether you remember or not. Let me write the present value 5V, 5V power 2, 5V power 3, 5V power 4, then 100 V power 4. Here you can say this is a 5-year problem. Then you write the times also. 1 here, 5 into 1 into V plus 5 into the time you need to write here, V square plus 5 into time 3 into V power 3, 5 into time 4 into V power 4 plus 100 V power 4. If you check this one, here you can take 5 common, okay? Then you have an annuity here, that is increasing annuity, IA4 plus 100 V4 divided by, okay, use this line. Next, you write here 5V and all that up to 5V4. That will be 5A4 plus 100 V4. You see, there is a particular form here. Okay. Say you are finding DMT at 10%. You can make use of actuarial table, and from actuarial table you can see this and you can put here. Even this one also you can see and put here. You can use a calculator, or maybe even you will get V4 also at 10%. All these things you can find and put here. You will get the final value. That will be your DMT. You can use a calculator. You can use the formula and you can put here. Then also you will get the answer. Now coming to the second one here, the notation is a differentiation, a dash divided by a dash upon a. There is a minus sign here. And convexity, for convexity, you need to find double differentiation. That will be a double dash divided by a. Okay. Now, how to take a differentiation? Let me tell you something on that. Here, if you write, say, for example, a, I write v power 5 here. Okay, then what is a dash, Savitri?
5A4.
5A4. Okay, 5A4. So you meant differentiation with respect to v. When I said you consider a dash to be dA divided by dV, right? But here we find differentiation with respect to I. So this is dA upon di, not v. So when you find dA upon di, you have to change it to y. Or you can write dA y dv. Whatever you said, we'll write that 5v power 4 into dv by di. Or v you change to I, it will be 1 plus I power. V is 1 upon 1 plus I, right? You can write here. Then take differentiation. minus 5, that will be 1 plus I power minus 5 minus 1 minus 6. This will be the differentiation. Okay, that is minus 5 v power 6 minus 6. Okay, sorry, v power 6, because v is 1 upon 1 plus I. So here you have a dash. So you can write volatility. You just apply the formula, that is a dash divided by a. So a dash, if you write minus 5 v power 6 upon here v5. Okay, if you differentiate, if you take this one, but we'll go to our own problem later. Now you consider another b here, b. So you write v power 7 directly without doing this way. You should remember b dash here, that will be minus 7 v power 8. Okay, then if you take c, right, v power n, c dash will be here in this chapter. This will be minus n v power n plus 1. Okay, just remember as a formula for this chapter. You see, we got it here. This power comes here with a minus sign, then we are adding 1, because here a dash means dA by di, not dA by dV. That's the reason. Even let me write 3 terms here, how you can differentiate. So then d dash will be minus 5 v power 6 minus 12 v power 5 minus minus plus 3 v power 4. This will be differentiation here. Now we'll apply this technique here, and we'll see whether vi is some connection with tau or not. Okay, let me write here. Let me write a dash first of all. Here a is the present value, this new denominator. Okay, so I want to differentiate this one. Let me write a here, 5v square, and the final one is 100 v power 5. Okay, so here if I differentiate, I will get minus 5 v square minus 5 into 2 v power 3, right, minus 5 into 3 v power 4 minus 5, this will come here 4 v power 5, then minus 500 v power 5. I differentiated. Okay, applying that formula, you take this one, you make this the power coefficient here, 5 was there before, and multiply with minus sign, then increase the power by 1. Then if you write minus a dash divided by a, I multiplied minus here so that every term will be positive. Take 5 common. Even you take v common also. If you take 5b common here, minus I multiplied here. Okay, so there will be no minus. So if you take 5b common, then we'll have v here, v 2v square 3v power 4, right? This is ia4. Here also if you take, okay, you keep it separate. 5 is here, 100 v5. Okay, we'll see later. Minus will not write because we have taken already here. Now if you see the denominator here, you have to write.
Sir,
Yeah,
be 100 into 4 into V5.
which one?
Differentiation of the term with 100 in it.
Mm-hmm. No, the time comes here, right? It's 5 already there.
But it's in the 4th year that the 100
Okay,
comes.
okay. We'll change here. Okay, fine. Okay. So we'll do it 4. That's all. Okay. All right. No, then how? Okay, 5 is common here. So 5 is there everywhere. I've taken 5 common here also. But where this 5 comes? Acha, 5 comes from this, right? Okay, 4b4. So yeah, that's okay. Now here in the denominator, we'll have 5 ia4 plus 100 v4. Still you have to get it 5. Okay, there is some problem even here. When I wrote here 100 V4, and the time here I wanted to write, I missed the time here. Okay, so I should have written 4 here also. Here you see 5 is the payment and 4 is the time. Okay, where is time here? So here this will be 400 V4. Okay, so in tau also you have to make a little change. This is your tau. Now you see this is minus a dash by a, that is Vi. So if you take just V common here, things will match. 5 Ia4 plus 100, sorry, 400 V4 divided by 5 A4. Here, this is A4, right? Okay. Now see, this part and this part, they're the same. So whatever way you do, this part is only difference is you have a V common here. So if you multiply V to this, you will get this one. Okay. Tau is this much. Okay.
So,
To
but
find, yeah, tell me. If you multiply 1 plus I to Vi, this V will cancel and you will get tau. 1 plus I Vi. You have to do this way.
so,
So
but then it's 400, it's not 100, it can't be cancelled.
yeah, and any question?
So it's 400 and not 100.
Okay, 400. Yeah. Anything else? No, I think
So
yeah, here also 400, right? No, here 100. So here also 100. Here also 100. Where 400 comes? Here 400. Because time factor is not here. Even if you check A here, 100 is here. So 100 comes here. Here there is no time. That's why 100. Here you multiply by time. That's how it's 400. Okay.
I'm saying it cannot be cancelled as a fraction.
Now how can you cancel? Because this here 5 is multiplied, right? You have to find this value. You can't cancel. Okay. This is even IA4. This is A4. You can't cancel. You have to find this using calculator or using your table. You have to calculate. Okay. Any other question? Are you fine with this? Savitri.
Yes, sir.
Okay. So let me delete this one. So remember, these are the 3 important measures. We have one is tau, then Vi, then Ci. And this is convexity, this is volatility, and this is your tau. Tau is DMT. Okay. DMT, then volatility, then convexity. Now, we'll do the most important topic of City 1, that is part 1 of CM1 today. These are the measures we'll use in that chapter. Okay. So, how? I'll tell you. Before going to that, let me tell you something. Else, like this one. Say you are asked to find tau here, and I'll give you random cash flows like 10, 20, 30, and 40. Okay. And you are supposed to find A is the present value, that's fine. You are supposed to find all 3 measures. How you would like to find? What is the best way you would like to find? I mean, you prefer the derivative way or the first way? Because say for example, if I write this way, A is equal to just write 10. You can find A dash. Okay. Immediately I can write 10 into V minus will come everywhere, right? So V square, this is 40. You take minus common. 40 V power 3 plus 90 V power 4 plus 160 V power 5. Then you can find Vi minus A dash by A, multiply minus. Even if you can do anything, you just find term by term and add, that's all. Always you will not get in the form of an annuity. Never mind, divided by this one. 10V, 20V square, 30V power 3 plus 40V power 4. It's over. Then if you want to find Ci, you take differentiation once again, you'll get it. And you write here in the numerator, double differentiation, and this is same. 20V square, 30V power 3, 40V power 4. So this one is double differentiation. You need to differentiate this once again, that's all. Okay, there is a minus sign here. Minus I multiplied here, that's why there is no minus here, okay. But here when you take double differentiation, another minus will come here, then that will also become plus, okay, that you need to write here. So this is a double differentiation divided by A, okay. So these two things you can find directly from the present value. Now tau, for tau you have two choices. Either you you find from Vi, because there is a link, tau is 1 plus I into Vi. Whatever you found here, just multiply with 1 plus I, you get this one. Or tau directly also you can find. You write the present value, this one, whatever you have written. Then you write times 1 into 10 into V, all these things you write. So either way you can find tau, this way or through this one, Vi, you can find. But what is the significance of tau? Let me tell you that. Let me delete this one. Listen carefully, okay? This is very important. Now suppose in high school classes in India, we give tuition fee to the teacher every month, okay? Say you are paying 1,000 at the end of first month, okay? Another 1,000, 1,000 here, 1,000 here. 4 times we pay. 4 times or whatever times you will, like 4 months, 8 months, 1 year, whatever time you study time period, that time period you have to pay. But now suppose the teacher says, no, I don't want to take 4 payments. You pay me once only, whatever time is required. At that point of time, you need to pay. So when I talk about the payments, all 4 payments, whatever the total amount, 4,000, you are supposed to pay at one point. Then that point will be DMT. Okay. Here you can take, if I write 1, 2, 3, 4, you can something like, if you find it will be something between 2 to 3. Okay. Because all the payments are the same. If you change the payments, it will change. This is kind of weighted average. Okay. Time weighted. Because now you have to pay 4,000. This is DMT, tau. Tau is the time. That is called average life. Why we talk about average life? That also we'll discuss today, if time permits. And I hope I will be able to complete this chapter. After this class, 1 or 2 classes more you need, 1 class more maybe. Now, coming back to this one, if I, okay, that's no more there. So let me write once again. 0, 1, 2, 3, 4. So if I write any like 5, say for example 100 here. So what happens is when you find DMT, you want to make all the payments at one point. Okay, you want to make all the payments at one point. If you want to make that, what is the point? What is that point where you want to pay all? Okay, that point. What should be that point? That is DMT. Okay, you find tau and write here. I think it will be towards 4 because where you have a cash flow, because we are considering these also cash flows. So 5, 5, 5 are little amounts. Okay. So if you choose a midpoint, the teacher might not agree. because there is a very heavy payment here. Okay, so this will drag toward this side. But remember, all the payments, whatever, 20 plus 120, all the payments you have to make at a point. Okay, so that point will be tau. You can check also, you can find the discounted value of all this, because you are using time value of money. That's why we're talking about time. Normally you don't make it your personal case. In that case, it could be the any point, like on mutual basis at 0, at 4, at other point you can give. But mathematically you take time value of money of all, and this 120 v power whatever tau you will get. Okay, tau you have to find using the formula. They will be approximately equal. So this is called average life of an investment. When I talk about life, I'm talking about only one payment here, no payments like this or like this. Why we want to make it one payment, I'll tell you. That will come in immunization. Okay, that's what we'll study today. Reddington, it's due to Reddington, remember, UK actuary. So he prescribed three conditions for a company to be immunized against small changes in interest rates. So what happens is, in any business, the small one is, if you consider any small company, okay, so what happens is the income and outgo you can't match. Okay, for any company, you consider our company also, the income whatever we receive, now we are paying rental payments at the end of each month, the staff cost and all this internet cost, all things will continue to pay. But our income, say for example, you got income like this, I'm writing plus. Okay, these are called asset and these are liability. Maybe you have some liability here, no income here. Here only income, no liability. Here only income. Okay, somewhere here you have liability, you have less liability, like that. Even if you consider yourself, you are working in a company, wherever you get money, at that point you will not spend all the amount. So maybe on first of every month you will have full positive cash flow. Okay, then something from some other source you will get like this. So what happens is, there are positive cash flows and negative cash flows in any business. Even personally also, you think we manage our finances. So what we'll do is, again, if you are from commerce background or not, I'm not doing anything about asset liability management here. Okay, asset liability management is different. We are doing something different. See, I will consider all positive cash flows. Only pluses I'm writing. 1, 2, 3 here. Then here 1, 2, 3, 4. And liability I will write here. Here I have this much liability, less liability. Here somewhat more. The third interval 1, 2, 3, 4, 5, 6, 7. Then something like this. These are the liability. So asset means whenever you get some positive cash flow, okay, you find the present value of all. If you find present value of all, that was already denoted by A. Now this present value is called VA. This present value is VL. Now it's not that we always keep all money in our pocket. We roam here and there. It's not possible. So everything in any business, everything is arranged with bank. Okay, the bank's interest rate they change whenever the central bank in India, RBI, they change the interest rate in the market. So other banks also they have to change. So because your liability and asset, suppose they are same now, present value of asset is equal to present value of liability, or we say the company is healthy when asset is greater than liability. Okay, now the concern is, suppose presently they are the same. Okay, the company is running fine, you have asset liability matching. Okay, now there is a fear. Okay, we have to write at high interest rate in the market is 8% now. Now say due to some reason interest rate increases to 8.2% or 8.5%, or decreases to, we use epsilon also, I plus epsilon. Okay, uh, I minus epsilon you can write, or you write plus, you take in epsilon minus 7.5 or 7.8%. So what happens is, if the interest rate changes, then they are now equal. Your present value of asset and liability, they match. So the company is healthy, there is no problem. But you are we are if we are part of a company, we are exposed to the interest rate. If the interest rate changes in the market, then the fear is, if your asset at I plus epsilon, okay, 7.8% or 8.5%, they will not be the same, because we are discounting all these cash flows, the times, the amounts, they're not the same. So maybe this will be less than or greater than, we don't know. The fear is, if asset will be less than liability, not due to your mistake, okay, like it was fine with interest rate, immediately the bank declared the interest rate changed, then your asset is less than liability, okay, then you are in danger. So immunization is a technique, okay. Just a minute. Immunization is a technique by which we make it sure that asset will always be greater than liability. Doesn't matter whether your interest rate increases or decreases. We use Taylor's theorems here, so the derivation is not required. Using Taylor's theorem, though derivation is only 7 to 8 lines, but it's not required. So this is reduced to three conditions. Okay. So these, if these three conditions are satisfied, then we say company is immunized against mild or small changes in interest rates, because Taylor's theorem itself is applicable in the neighborhood. Okay, 8 to 8.57 point, within 1%, it's fine. If the interest rate changes to 5-7%, then immunization theory will not work. Okay, I'll even I found the notes. I'll send you after the class. The time is over. I'll give you one problem. Just do that problem. Okay. So how we are doing? I think another 15 minutes is required on this.